Okay. Now, the example which I gave just now, that is the wedding planners, this is an example of event-based uh, companies or organizations. Event, that is like the event is wedding planning, okay, wedding. Subscription based are different kind of idea or concept where customers go again and again to the company. For example, supermarkets. So I saw there is a Vishal Mega Mart in Shimla, right? So I don't know if I never been to Vishal Mega Mart, but think about a Walmart. No, Walmart is in America, but let's say Geo Mart, okay? I'm sure there is this, right? Geo Mart or something, Reliance Mart, yeah. So they might ask, sir, would you like to have a card? And you will say, and you will get 5% or sometimes 10% concession on if you have this card, right, on the products. But and you have to tap this card every time you do shopping. What's happening in the background is the companies are tracking what transactions you have made, okay, what products you have made, how much money you have spent, how frequently you are coming, okay. So when they have all this information for you, they can predict that what's the lifetime value of this customer is for X number of time period. X could be next 5 years and 10 years and so. So naturally, and when you are predicting this value, lifetime value, this value is a continuous number, right? I'm sure you know continuous, right? 0 to positive infinity theoretically. So, and we would like to predict this value. And naturally, this question is a regression problem, right? Because in regression, you try to predict what is the positive or whatever. I mean, theoretically, we always go for a positive value. And what is the value between 0 to positive infinity, what this value customer can bring. Okay. I will move, I mean, I don't think you are recording me, right? No. Okay. It's not needed. So, and some more examples, event based, if you are moving from, let's say, Shimla to Palampur for your job, right? It's an event based and you need packers and movers. You don't move so frequently, right? Subscription, I think I already gave some example, retail, banks, telco, hairdressers. Uh, is there any saloon in Shimla which says that take this card and if you get 8 haircuts, 2 haircuts are free? There is no concept, okay?
There is one.
There is one, okay, so there is one. Actually, it's very common. Actually, when I was in Singapore, I came to know about this Chinese guy, hair cutter there, so not hair cutter, so how did barber, uh, and he was giving, if you take 9 haircuts, the 10th is free. So all the students go there, okay, so he has this card. So it's a subscription based, right? He knows how frequently these customers are coming, how many customers he has, and so on. Okay, so I think I briefly talked about customer lifetime value, sorry, stages. Uh, think about there is a marathon going to happen. Does marathons happen in Shimla? Okay, people have good stamina. Okay, so let's suppose there is a marathon which is going to start from race. Okay, and and people are doing registration there, and there is a new startup company related with bio or ecological products, organic products, and they are in the market. They think this is the best place to attract customers. Why? Because all these people who are going to run, possibly they are very health conscious, okay, and they have put banners at the starting point so that all these people can see next to the registration counter of this marathon and so on. So and what they are doing, basically they are giving a small energy drink for free. Let's suppose it's not Red Bull, okay, it's really a nice organic health related product drink. Now they will say, but when they are giving this, they are asking customers, fill this small form. What is your age, gender, income, okay, are you single or married, and so on. Because what are they trying to see? whether it's going to be a potential profitable customer or not. This is what their idea is behind. So at that point, they are targeting the customers. That's the first stage of life cycle management of the of customers. Okay, so when, and again it depends on the company or the domain. Some companies, like for example telecom earlier, I think maybe decade back, as I said before, Geo entered the market and was very disruptive, right? Uh, people, telecom people thought if a customer stays for 3 months or 6 months, no, let's talk about the new customer. So somebody enters, so the customer has made a kind of registration, filled the registration form, and for 1 month he's a new customer. And if the customer stays for 3 months, it's a kind of loyal customer. Okay, but let's take a scenario of bank. In banks, if a customer is there for 5 years, then they will call them loyal customer. But in telecom or mobile, people say, okay, 3-4 months are there, he's a loyal customer. So it depends on the domain. And when a new, suppose, plan comes, a new bank comes in the market, it's giving free credit cards, there are no charges, no limit, unlimited times you can take out cash from any ATM, then customers will leave this bank and go to some other bank. Okay, this is called churn, and we will talk about in the classification. So we call it churning has happened, CHURN, churn. Now customer says, okay, my original SBI bank was better actually, they were giving better service, right? Although they were a bit late lateef, not good as Axis Bank or some other bank, but let me go back. So we call it returning. So the customer is returning. Okay. So these are the different phases we talked about. And similarly, when the churn happens, sorry. So after that, they would like to retain the customers. I mean, retaining also happens in companies also, where the people would not like their employees to leave. That's a very bad thing when good employees leave, right? And then maybe the customer, for example, not now, but at some point we had this Tata Docomo landline. So we had this phone, landline kind of phone at home, maybe again more than a decade, I guess. And we decided that they are not giving good service, and we are not happy with the bandwidth and whatever, and so we decided to close. So there was almost every day somebody was calling us from customer care. Okay, sir, we are giving you free plan for next 2 months. We are giving you this. Why? Because getting a new customer is very, very costly, but retaining an existing customer is very cheap. Okay, you give them few kind of plans, and after 3-4 months, customer will say, okay, it's fine, let's stick to who will go to another service center, take a new plan, and so on. So retaining and win backing the customer is different phases. So let's talk about let's start quickly to customer lifetime value. I would also see my mobile in between. Okay, so this has different names. Some in literature they call it lifetime customer value or lifetime value, and so on. Okay, one way to identify is basically through historical, lifetime value. So you know that, let's go back for the time this customer has associated with the organization, and let's see how much money he or she or whatever they have spent, right? And what you could do, you can use this recency, frequency, and monetary. We discussed very briefly yesterday. Okay, We discussed, right?
Yes,
Or no?
yes.
Okay. So, but the problem with this RFM concept or historical approach is that you cannot use this information to predict. It's not possible. You can only go back and see what is happening. If a new customer comes, you have to wait for another 5 years to see what is the customer lifetime value. Okay. Now, the predictive lifetime value. Now, when a new customer comes, oh, we have to discuss briefly lazy learner. Lazy learner. Did you check? Okay. Please remind me. I will talk about this lazy learner. Okay. So in the predictive part, what is the difference? When the new customer comes, they can even predict what would be the lifetime value, which historical techniques cannot tell you. Okay. So let's think about a scenario where there are 4 customers. Okay. And this 2, 3, 5, 6 is the number of products they have bought. I hope I'm not blocking the view, right? You can see. Hmm? So on the y-axis is the customer lifetime value. Now, it's a toy example, and if somebody has bought 2 products, the lifetime value is 2 million. These are existing customers, and using that you have plotted it. Now, and what you did, you said that, okay, these are the, dots that you have put it in the map, and each way has a x and y value, right? It's very easy. Now, let's consider that the new customer has arrived and he has bought 4 products, and you would like to predict what is the customer lifetime value. Okay, let's draw a line and let's project this number of products on this line, and let's move to the y-axis. And this is a very naive approach to kind of predict what would be the lifetime value of this new customer, and this is basically linear regression. Okay. Now, you know the difference between unsupervised and supervised, so I will skip it. You also know the mathematically difference between these 2 concepts, right? So I will skip it. Regression is a continuous value, but when you have to predict discrete classes, discrete means limited number of classes, then the problem becomes classification problem. Favorite example to demonstrate linear regression. Let's try to predict the exam performance based on the sleeping hours of the students. It's very personal, but forgive me. Okay, so let's suppose what you have done is you collected the data of second year which is not in the class, right? If you are in the second class, don't tell your friends. So what we did, that we have second year students whose data we collected, we know their marks, and we know how many hours they slept before the exam. And what we did, we plotted it. Okay? And basically, what we did, now we would like to fit this data. We call it, we would like to fit this data. Okay? This fitting will be clear in a moment. What it means is basically, we would like to fit this line in such a way that each point is asking, come close to me, come close to me. Okay? Somebody is in demand. So, what we want is that, and as I said, these machine learning algorithms cannot give you always the perfect results. Sometimes they are approximated. They will have errors, right? So, and we have to live with it. And what we are trying to do is that we fit this line in such a way that the setting of this line is as close as possible to all the data points which exist. Okay. Now, this is the real point. This is the real point, the black dot, and this blue is the projected data point, and this blue dotted line is the error. Okay. This is the error, and this error we are going to calculate for each and every data point. Okay. once we have done that, we call it sum of squares error, right? Can, I mean, why are we doing square here?
So that there is a negative.
Why are we doing square here? Anybody wants to answer? Last bench, second last. Avoid what? Sorry? Exactly. Because if you don't do the square, some will be positive and some errors which are below will become negative, right? The projected minus this will become negative. And if you start adding them up, plus values will negate the negative value, so it might become 0. We don't want to do that. So that's why we are doing sum of square errors. You can even do a sum of square of the square root of that if you want. So this is not hard and fast rule that sum of square error is the perfect error. Okay, but it's the more prominent and in fashion. Okay, so this is what we did. Now we did it one time and we got this sum of square error. Now in another time we move the line little bit up or down. We again calculate the error and we keep doing this for multiple times till we get a line which has the least error, and the line which has the least error we will say that this line fits the best for all these data points. Now when you do this scikit-learn, you have this function called dot fit. This is what is they are doing, fitting. They are fitting the line. Okay. Scikit mein hai na command data points, yeah. So this is basically what is happening. They are fitting the data. Okay. Okay. So you know how to calculate this the best way. Now a question can come. This means that we have to move this line n, and n is like not really close to infinity but a very large number, right? My question is clear, right? No. As soon as something is not clear, students like मुझसे ना पूछ ले गई. Okay, so the question is clear or no? Okay, so as I said, here I am using the toy example, right? Here I just said ki chalo line we moved here, another time we move the line little bit like this, another time we move the line little bit down. But if we keep doing that, there is n number of ways to move these lines for this data, right? It's a problem. What is the solution for this? So I mean, this way we will have n number of ways we can move this line, because you can have different slopes, different coefficient. This is clear now, what is slope, what is coefficient. You can use these different slopes and coefficient at n number of places for this data, and n is a very, very large number, right? Could be many different ways. So how can we in a limited way quickly find the best line? नहीं उठना नहीं, बस जोर से बोलो.
ट्रेनिंग एक टेस्ट
नहीं ज़्यादा हो गया, अभी रुको. We have not reached that part. Any other answer? That's what I am saying ना. How we will know कि यही है सबसे कम वाला error? Hit and trial is one way, but that way we have n number of options ना. Anybody? नहीं रुक जाओ. So at least I am happy that I can tell something new. So what we did, any answer? Okay. So what we did just now is simple linear regression, right? On x-axis there are values and y you are going to predict. This is simple linear. If you are predicting y-axis, y we call it dependent variable. X is the independent variable. Okay. And this is like the mathematically, this is like the slope, this is the coefficient. Okay, so the angle is the slope. And what we are trying to predict here is in such a way, so there is also which we didn't discuss about is that uh, uh, this error. Okay, generally we do not consider this error, and I'm not going into that. Okay, so the x is the input, different names for it, y is the output, different names for it. Okay, and beta is the coefficient, and alpha is the intercept or slope. Okay, don't worry, scikit-learn will give it to you, but also it has a technique in itself inbuilt, which in a limited way it tries to find out what is the best fit line for this data. Okay, so this is simple linear regression, and now we are moving towards how to find what is the way to find this line quickly. Okay, so what we are basically doing is basically we want a line which has the minimum error, but how can we find it quickly? We can find it through a concept called gradient descent. पढ़ाया था, याद नहीं था. Okay, so gradient descent is a concept. You know this concept, right? Question?
Afterwards.
Okay.
After this.
So I'm not going into how this gradient descent works. It's basically a kind of differential thing, okay, where we try to minimize the error. Okay, but concept wise, let's consider that somebody is on the top of the mountain. Is the best way to explain this idea in Shimla. Mountains. To somebody, I mean, if I give this example in plains, it's fine, but here we can relate. Wow. So somebody is on the top of the mountain, okay, and he or she has to go down, but down at certain point. Let's say Victory Tunnel. Okay. Now you know there is a certain road which will take you to that road, right? You can't go there. Let's go here and there and let's go, because you have limited time, limited resources. And let's suppose, I'm sure you know this Iron Man movies, right? So have you seen this Iron Man? Okay, very good. So he has these propellers in his feet, right? And he can jump. So think about somebody has propellers in his feet and he's jumping. He can jump as much as he or she can. Okay, and this bottom blue point is the destination where this person has to reach, starting from the top of the mountain. So what this person can do is it can take long jumps, okay, and then somehow when it's reaching towards the bottom of the mountain, it decreases the step size, okay, or the width of the whatever you would like to call it, the jump, and slowly it can reach towards that point. So initially you take long jumps, and then as you start seeing that you are reaching the bottom of the mountain, you take small steps, because at that point you have to reach. So mathematically it's again you would like to reach the local minima. Mathematically you have to reach local minima, and I will use this pen. I don't know if that figure is there or not. I'm not sure. So okay, so think like this. Okay, so what you do is that and this is like the error. Okay, this is like the point you have to reach. It's okay, it's okay. You take big steps, and then once you reach at the bottom, you take small steps. Okay, this is the concept behind gradient descent, and this is the way how these algorithms, even scikit. You have a question? Asha. So this is the way scikit-learn also at the back end, they try to find this best fit line quickly. Okay. I think you know how to do it in Python. Basically, you call these functions